let's take a general example where we will calculate all these parameters without remembering this formula. So the question is an angle modulated signal with carrier frequency omega c equals 2 pi into 10 raised to the power of 5 radians per second, and is described as follows. Phi exponential modulation is equal to this. The signal is given to you as this. Find the following. First of all, the first parameter is power. So power is simply a square by 2. Here it will be 10 square by 2 and hence 50. Frequency deviation delta f. For that we have to first calculate omega I, which is d theta t over dt. So we take the derivative of this, and this is the derivative that we have got. And after that we have to calculate the maximum value of quantity in bracket, because this omega c is already known to be fixed, so we do not care what its value is. And then inside this bracket, whatever is written, what is the maximum value of that. We know that sometimes it will happen that this cos and this cos will add up constructively, and they both will have a value of 1, and ultimately you will be left with 15,000 plus 20,000 pi. So the addition of that is your delta omega, and delta f will be hence delta omega by 2 pi. So this is the value. So here we see that frequency deviation is nothing but from instantaneous frequency we calculate the value of quantity inside the brackets, the maximum value of that apart from omega c. Then third is the phase deviation. Phase deviation is calculated from the complete angle. So you have written this angle as nothing but omega ct plus this complete angle is here, and phase deviation is nothing but it is the maximum value of the quantity inside this bracket. Means apart from omega t, whatever is the maximum value of this will be calculated. So we know that it will be 15 radian because the maximum value of this will be 1, the maximum value of this sine will be 1, and 10 plus 5 is 15. Now we need to calculate the deviation ratio. Deviation ratio is easy because we have already known delta f, and we need to calculate bandwidth only. So here the bandwidth of the signal, can we do not know whether this signal is your FM or PM signal. So had it been a FM signal or PM signal, the bandwidth will come out to be the same for both of them. Ideally this bandwidth should have been given in question, because we do not know in what way this psi t has been calculated. But assuming that it is either FM or PM, if you calculate it, the bandwidth will come out to be this only, because bandwidth is the maximum frequency component, and if you calculate it in hertz, 2 pi will be divided. Even if it is a phase modulated signal or frequency modulated signal, so you take either this or its derivative, the maximum frequency component will remain the same. So the bandwidth will come out to be this only, and that's how you can calculate this beta or the deviation ratio, right? And since in this case we do not know by what signal we are modulating our carrier, so it is called as deviation ratio in general. Had it been the case for only sinusoidal signals alone, we would have called it something different. We have already discussed this in previous video lecture. Then bandwidth of the modulated signal, that is exponential modulated signal, that is twice of delta f plus b. So it's a very formula based problem, but here we have just shown that even without knowing whether the signal is FM signal, PM signal, or any general signal in between, we can calculate all these parameters easily: power, frequency deviation, phase deviation, deviation ratio if bandwidth is given, and bandwidth of the modulated signal.